welcome back to Engineering Nature. Today we are going to learn about the dynamic mesh option which is available in ANSYS-Fluent. To learn about this dynamic mesh, I had selected this piston cylinder geometry in which piston is moving towards the top dead center. During this action, the cylinder wall will be deformed. This event we can incorporate via dynamic mesh through two different methods, that is smoothing and layering methods. So today I will show you how to use the smoothing and layering options in the dynamic mesh method. So let's start. It's very simple rectangle. You can create that geometry in design modeler with given dimensions. I had created this rectangle of 95 by 120 mm dimensions. Now you just create a simple mesh with the ANSYS meshing. I had generated very simple mesh with almost 200 element. My purpose is only to demonstrate the dynamic mesh, so I am not refining the mesh. These are the boundary conditions which I had considered. These all are walls. Bottom portion specifically I mention as a piston. Two side wall I mention as a cylinder wall. Now let's switch this geometry and mesh to the Fluent. Now in the Fluent setup you can check the scale. I am using the millimeter scale. You can check the mesh which you had imported. Now these are the element which I had imported, where we have piston, this one is top wall, this one is wall surface and interior. Now I am using pressure wave solver with unsteady simulations. You can also enable the gravity options. There is no multi-phase flow. You have to enable the energy equation for this particular case. For sake of simplicity, we are using only K epsilon standard model with enhanced wall functions. Now in the material sections, the air is perfect for us. You have to ensure the air should be present in the cell zone conditions. Now in the boundary conditions, let's define the boundary conditions. So boundary type should be wall, and it is stationary wall here, and just I am considering there is adiabatic condition, so there is no heat flux. Now this is important part. You have to go open the dynamic mesh option and you just enable this dynamic mesh. Once you enable, there is a two methods, smoothing as well as layering options. So I just keep default factor. For layering also you can set the layering factors. So these are the factors. Now in cylinder options, you can set all engine parameter. Now let's create the dynamic mesh zone. You have to click on the create. There you have cylinder wall as well as piston. Now our cylinder wall must be a deforming type. You have to select the deforming. You have to incorporate the radius of the cylinder and just define this cylinder, and it will move in along the y-axis. In case of piston, it's a rigid body which is moving with this motion. You can define as a piston full. You just select on piston full, it will automatically care this lift per stroke options. And now the direction of motion is in y direction, negative y directions. You can also define the cell height during the deformation, and you just create this two dynamic mesh event. So you can also check the preview. let's check the preview. So these are the piston which is rigid, which is moving in the y directions for 360 degree. What we are defining 360 degree, number of time step is 2. So this is how piston will move. Now you just go to the solutions, where I had simply select all default setting, and in the control you can set the controls if there is a conversion issue. Now I want to export this all reports, so you just select that. You can set the residual value. Just I'm keeping this as it is. Now you just go to the calculation activity, where you just click on run calculation, where you can just define the number of time step, that is 360, and the intermediate time step already they are calculated. Now you just calculate the solutions. Let me show the result. So in the result, let me start with contours. These are the pressure contours which I had obtained at the end of simulations. These are the velocity contours which I had obtained. Now my intention is to show you the actually the animations which I had got. So let's move to the animations part. So this is how during the dynamic action of piston, the mesh will deform and piston will move in this way. So this is the dynamic deformation which you can incorporate via dynamic mesh option. These are the pressure contours continuously change during the dynamic mesh. When the piston move upward direction, the higher pressure will be located on the top dead center, and these are the path line which I had captured during the suction stroke as well as compression stroke. So that's it for this tutorial. Thank you very much.